In this video, we will demonstrate the initial work undertaken in the fault analysis task in the Compass project. We will show preliminary results, a simple model defined using a HiP-HOPS profile in SysML, our proof of concept tool which enables HiP-HOPS fault analysis of SysML models, and finally, we shall show the fault analysis results on a simple model. We begin by looking at a simple SysML model. This model conforms to the HiP-HOPS for SysML profile created in the Compass project, which allows a SysML model to create models with the required fault analysis markup. The example we use as a demonstration is a standard example that comes with the HiP-HOPS tool. The profile has been designed specifically for systems of systems, and as such we use SOS terminology, even though we acknowledge that this illustrative example is not an SOS. We have a number of different views which illustrate different aspects of the model. We begin by looking at the SOS composition view. This view shows that the SOS contains two constituent systems, sensor input and standby recovery, and a line, line 1. Each constituent contains a collection of ports and at least one implementation. A line, in a HiP-HOPS model, is a multi-way connector which represents the flow of data or other materials through which failures may propagate. In the next view, the SOS connections view, we show how the constituents are connected, and we show which connections represent each line. The next view, the implementation failure definition view, details the basic failure events of an implementation, and also the output deviations for the implementation in terms of those basic events and any input deviations. The model elements such as SOS, constituent and basic events are defined in the SysML profile along with appropriate tags. Derived tags allow Artisan Studio to automatically complete some of the model attributes. Once we have a marked up HiP-HOPS SysML model, we may use the SysML to HiP-HOPS tool. This tool, in an early stage of development, generates an XML file which conforms to the syntax required for the HiP-HOPS tool. We begin by providing the destination for the generated XML file. In this video, we simply choose the desktop. Next, we identify the HiP-HOPS model element in the SysML model. It is important to note at this stage that Artisan Studio must be running with the HiP-HOPS model open and the top-level model element selected. Having obtained the SysML model, we generate the XML representation. The tool will navigate the SysML model in Artisan Studio and produce an XML file which complies with the HiP-HOPS XSD description and ensures compatibility with the tool. We may now view the XML file in a web browser by clicking the Open XML File button. Finally, we may send this generated XML file to the HiP-HOPS tool. To do this, we must first select the directory in which the HiP-HOPS tool is installed. The HiP-HOPS command line tool is automatically invoked with the generated XML file provided as input. When the HiP-HOPS tool has completed processing the model, a web browser opens to show the results. From here, we can view the fault tree for an omission on the output port of the standby recovery constituent. The tree can be expanded to see the AND and OR gates and the leaves of the tree. Each leaf of the tree corresponds to a basic event in the SysML model. For each fault tree, we can obtain its cut sets. These show the sets of basic events that will lead to an overall system failure, each with a corresponding unavailability value calculated from the model. In this case, each cut set only has a single element. The unavailability of the overall system is calculated from the unavailability of the cut sets. Finally, we can see the failure modes and effects analysis tables for the basic events identified in the cut sets. These show what system-level failures a basic event may contribute to, the severity of that failure, and whether it is a single point of failure or not. FMEA provides the bottom-up analysis of system failures, whereas fault tree analysis is top-down.